So welcome back. In today's lecture, I am going to talk about vector spaces. Okay, and you can see that I have given topic that discussion on vector spaces. It means that I am assuming that you are familiar with the definition. Okay, obviously I am going to revise it, but our more concern about the application. Okay, that how basically vector space is involved whenever we are performing some kind of mathematical modeling. Okay, and whenever we are talking about state space representation, at that particular time what kind of spaces are involved, we are trying to learn in this particular lecture. Okay, so before going to the formal definition, let us take very simple system, and I have already talk about this system. Suppose I have some kind of mass here, and after that I'm going to apply some kind of force, and suppose this force I have defined like Ft, and after that now what we have to do, I have to assume something. And what kind of assumption we are actually doing in this particular lecture? I am assuming that this mass is moving in this one dimensional plane, and after that I am recording the position xt. Okay, and I have some method to measure the velocity also, and after that we will come up with this mathematical model. We have already seen about this ft. Okay, and in a state space representation, what we found that this is, I am assuming x1 equal to x, and x2 I am going to assume as a x dot. Okay, whenever we are assuming, then we are using this kind of symbol. And in this particular representation, this is also called modeling by first principle, because I am going to use some kind of law, second law of Newton, to model this particular system. Okay, I have done several assumptions here. I am assuming that whatever xt, that is two time differentiable, so this kind of assumption is inherent. Okay, after that if you represent this system in this form, then I have x1 dot equal to x2, and after that x2 dot equal to ft by m. Okay, and I am assuming that m not equal to 0, so I have some kind of mass, and after that I can also able to rewrite this equation like this: x dot equal to ax plus b into u, and where what I am assuming that this vector a is nothing but that is 0 1 0 0. Okay, and here b, what I am going to assume, that is nothing but 0 1 by m, and after that I am assuming this u as a ft, and here this x I am going to represent like x1 and x2. Anyone has confusion on this particular mathematical model or state space representation? Anyone? So this is called modeling by first principle. Okay, and what kind of principle I have used? Whatever law that is given by the Newton. Okay, so here if you see the representation of this system, then I have used the first set of first order differential equation to represent this system. Okay, now try to see this system carefully. Here if I want to know that how basically a state is evolving, then I need some kind of a space. Okay, so what kind of a space is required to understand the evolution of this state x and x dot? Here I have two state, position and velocity. We have already discussed why x1 and x dot are the state, because if you know the initial condition of x and x dot, then you are able to understand the futuristic trajectory. Okay, now here you can see that if I want to know how basically states are evolving with respect to time, okay, then I have to do this kind of plotting. Either I will take one state variable x1 and plot it with respect to time. Similar kind of things I can do that I will take the second state variable x2 and I will plot with respect to time. Okay, so one way to understand that how basically state are evolving with respect to time. Another way, suppose if I forget about the time, okay, I am not concentrated on the time, I just want to know that basically how x1 and x2 evolving with respect to each other, and this is called phase plane analysis somehow. Okay, so forget about the name, just you can see here that in order to note the evolution of this system, this simple system, simple mechanical system, I need some kind of a space, and that space is two-dimensional space. Or you can also interpret like that, if I take any point in this space, that is represented by some kind of column vector, where first entry some kind of ordered entry I have, so I can represent either like this, or you can also able to represent using some kind of row vector. Okay, but most of time we prefer the column vector. Okay, so equally you are able to represent by column vector or row vector. Okay, if you see why people are preferring column vector, from here that is obvious. Okay, so if you are writing in form of column vector, so x dot is x1 dot and x2 dot, then representation become easier. Okay, so most of time in literature people are talking or representing this system in some kind of column vector. Okay, so here what kind of a space that comes into picture? Here I have two-dimensional space, and how basically we are going to represent element? We are going to represent using column vector. Okay, it means that each element is going to represent by some kind of vector that is on column vector. Okay, and a space is two-dimensional space. Now if I generalize this thing, okay, generalization means what I am going to do, I am going to now do not worry about A and B. Okay, so here A and B, you can see that A and B is nothing but some kind of parameter of the system. Okay, some kind of parameter that comes into picture in form of A and B. Okay, so now in place of this circuit, if I change the circuit, if in place of this mechanical system, if I replace it by some kind of electrical system. Okay, so and those kind of example you have already done during your electrical engineering course or some fundamental course, those who are not from electrical engineering background. So suppose that I have some kind of voltage Vt, I am assuming that is time varying voltage, and suppose I have some kind of resistor, I am assuming I have inductor, and I am assuming I have capacitor. Okay, so now could you please guess that what is order of this system? Anyone, could you please guess? Anyone? Could you please guess what is order of this system? I have RLC circuit and I am assuming that I have some kind of voltage. Okay, so this is second order system. Okay, how many states are involved in this particular system? Two state. Why?
The second order system.
Okay, physically could you please justify? You can see here I have only two way to store energy. Okay, resistor is not going to store any energy, so whatever information that is going to come to resistor, okay, they are going to dissipate, but capacitor and inductor both can actually carry the information. It might possible in form of voltage or current, I am not going to discuss that, but somehow they are memory, some kind of element which has certain kind of memory. Okay, and whenever we are seeing the state, so state is also some kind of variable which can actually carrying the memory. Okay, and due to that reason I have two element which is responsible for carrying the memory, and due to this reason I have two states. Anyone has confusion on this? So whenever you have to guess the number of state variable in any physical system, just try to identify that what kind of variable which is going to store the information. Okay, in any form. Okay, if you have some kind of heat sink, then try to understand that which variable is going to actually gather the information of heat. Okay, in this way we can able to identify the state space variable. Binay, are you trying to ask something? You have any confusion, Binay? Okay. So now here you can see that I have two memory variable. So due to that reason, I have second order system. Now what I am going to do, I am going to perform the mathematical modeling, and I hope that you all are already well aware that Vt equal to VR means voltage across the resistor, voltage across the inductor plus voltage across the capacitor. Okay, and after that, just now based on the experiment, I am going to write the law. Okay, so here again, since we are going to use the experimental fact, due to that reason this is also modeling by first principle, and due to that reason I am going to write here R into IT, and I hope that you are all are already well aware about that. Due to that reason I am not going to discuss much. L di by dt, and here you have to actually calculate the voltage, and you know that Q equal to CV, and due to that reason Q by C I have to calculate, and I just know the current. So from the current you have to calculate the charge, and due to that reason I have to I don't know what kind of charge I have. Due to that reason I am going to integrate from minus infinity to some time t, and this is I tau into d tau. Okay, and that is divided by 1 by c. Anyone has confusion on this modeling by first principle? I have just written all kind of law, and here I have used Kirchhoff's voltage law. Okay, now here you can see that I have some kind of integral term. Okay, but whenever we are representing any system in a state space form, at that time we are not involving any integral term. Okay, and due to that reason I am going to do, I am going to take the first derivative. Okay, so suppose if Vt is constant, if this is some kind of DC voltage, so obviously this is 0, but I am not assuming that is constant. So V dot T comes into picture, and after that here I have R and Ri, so di by dt, and after that here I have L d2it by dt square, and here I have basically differentiation of integral. So definition of integral from using I by C. Anyone has confusion on this mathematical model? Now if you represent this system again in a state space form, you can see that I am going to assume as a x1, and I dot I am going to assume as a x2. Okay, and again if you represent, please do by yourself. It is possible to write, again I can able to write this system ax plus bu. Okay, so please guess what is a and b, just by equivalence you are able to do. Okay, so I think that means this is very easy task, and due to that reason I leave for the homework. Okay, now in this particular representation you can see that same kind of representation comes into picture. Okay, here I have just considered one mass unit m amount of mass with some force, and here I have considered the RLC circuit and some kind of variable voltage source Vt. Okay, same kind of mathematical model comes into picture, just interpretation of x is different. Okay, so could you please guess that what kind of a space here comes into picture? What is element of a space? Because we are going to learn the vector space, and due to that reason first we have to understand clearly what is meaning of a space. Okay, so here you can see that again my space is x1 and x2, because I want to know that how basically x1 and x2 evolving. Okay, what is futuristic value of x1 and x2, and if you see x1, so here this is it and this is I dot t. Okay, so here if you take any element in this space, that is current and rate of change of current is the element of this, and again this is represented in form of column vector. Okay, during this particular analysis I have taken two systems, but you can take infinite many system. Okay, and it is possible to show that a very large class of system where just this matrix is going to change a and b, that is going to depend on the parameter. Okay, here in case of b, if you see carefully, then mass comes into picture. Okay, if you see here, if you calculate a and b, at that time some kind of parameter like RLC is going to involve. Okay, so inside a and b, again parameter is going to involve. Okay, and you know that I can adjust RLC. Okay, so if you are adjusting RLC or if you are changing RLC, then what kind of quantity is going to change here? Anyone, could you please tell? Okay, before going to that, could you please guess that what is dimension of this matrix A?
2 cross 2.
2 cross 2 matrix. Okay, and if you see this matrix carefully, then A belongs to some kind of, each entry is real number. Okay, 2 cross 2 matrix. What is dimension of B?
2 cross 1.
2 cross 1. Anyone has confusion, then please let me know. Okay, so here you can see that A is 2 cross 2 matrix where each entry is real number. Due to that reason, using set theoretical form, and here 2 cross 2 means I am telling that I have some kind of order. Okay, orderedness means I am going to consider two row and two column. Okay, similar kind of things here. Okay, now here you can see that based on the system parameter, A and B matrix is going to change. Okay, so if now I am going to find the space. Okay, so could you please identify the space here? In case of first, you try to identify the space of matrix A. What kind of a space comes into picture? Anyone? Suppose I am going to represent the element of this space. Okay, so how to represent the element? Suppose I want to represent this element. Okay, so is it possible to do like this? I will put one entry as a 1 0 0, second entry as a 0 1 0 0, third entry that I am going to do like this, and fourth entry I am going to do like this. And after that, if some element that comes into picture, then I am going to scale these four elements, and after that I am going to form A. Is it possible? Is it possible or not? Yes or no?
Yes, sir.
Yes, this is always possible. Okay, now could you please able to guess that here element of this space in which form? Here you can see that in first example, whenever we are talking about a state, so at that time that is in form of column vector. Okay, so I can tell that, okay, a state I am going to represent using column vector, so I am going to represent those kind of a space where each element in form of column vector. Okay, now I am going to consider the second space where parameter is going to lie. Okay, I have taken just two system for time being, and now I am going to see that in which space parameter is going to lie. Okay, and this matrix A and B is responsible for the parameter. Okay, and it is possible to show that here the each element in form of matrices. Okay, so I have some kind of a space where each entry can be represented using matrix. Okay, so I have each element in form of matrix, and we are telling that a space associated with matrix is matrix space. Okay, I am not telling matrix space, please be careful. Okay, so I am telling that here I have a space where each entry can be represented using some kind of matrices. Okay, anyone has confusion? Now you are able to draw this also. Okay, that is not a difficult task. Anyone has confusion till now? So are you able to understand that a space, whenever we are talking, so a space might be two dimensional, might be n dimensional. Okay, and a space might be in form of some more complicated dimension. Just now we are trying to identify the element in that particular space. So element either in form of column vector and matrices. Okay, now we are going to see something else. Okay, what I am going to do, suppose some system is represented by x dot equal to ax. Okay, so I am going to take the general system, and after that obviously here I assume that you have some background. Even if you don't have background, then also it is possible. Suppose I have this kind of system and I am assuming here that xt belongs to Rn. Okay, so obviously this is n cross n matrix. Okay, B, I am assuming that not about B, I am going to assume something about the U. Ut I am going to assume that that belongs to Rm, m number of entry. So could you please guess the dimension of B? Quickly please guess. What is dimension of B? Real number. And could you please guess n cross m? Anyone has confusion on this? Because ut is m, due to that reason n cross m, because here if you see carefully, then this is n cross 1. So I have to match the dimension. Okay, so this particular model is general model, and this is also called linear time invariant system. Okay, so linearity will satisfy, or time invariance means that if suppose you are going to record some kind of output like xt, okay, and if you shift this by t minus tau, then y is also going to shift by same amount. Okay, so do not go in that particular terminology. Just you can assume that you have this kind of mathematical model x dot equal to axt plus but. Okay, now if you see the solution of this, then I can able to represent solution like this. Okay, so here you have to believe on me. So I am going to write general solution t minus t0. Those who has done course on modern control engineering, they are able to understand this solution EA t minus tau B u tau d tau. Okay, it is very easy to check. What you have to do now, you can differentiate it. If you differentiate it, it is possible to show that again this kind of things comes into picture. Okay, in that way you can able to verify that whatever solution I have written. Okay, and during, if you remember, during your JEE preparation, you might have seen this kind of differential equation dy by dx plus px equal to q, something like that. Okay, so that kind of differential equation, that is just same kind of differential equation, but it is generalized one. Okay, and after that we are calculating the integrand factor, and after that we are actually solving it. So same way one can solve it. Okay, so just please verify that this is the solution. Okay, now could you please guess that what is xt? X I have assumed that n cross 1 matrix. Okay, so if I this see the solution, okay, so what kind of actually a space is n dimensional space? What is form of each entry? Okay, I am telling that, okay, that is because I know that a state can be represented in form of column vector. Okay, so could you please guess the entry of column vector? Okay, I will give you the hint. Is it possible to show that this is nothing but some kind of function? Anyone has confusion on this? I am assuming that xt is some kind of function phi that is depending on t0, that is depending on t, that is going to depend on xt0, and that is going to depend on ut. Anyone has confusion? Anyone? I have defined like this. So could you please now guess that I have n dimensional space, and where each entry in which form? So what we have seen that I have a space. So two kind of space I have identified so far. A space where each entry in form of column vector, a space where each entry in form of matrices. Now I am going to talk about different space. Okay, after looking towards the solution, what we found that each entry, because x belongs to Rn, so here phi is also n dimensional function, and more clearly you can write phi 1, phi 2 up to phi n. Okay, and obviously in the form of column vector. But if you see each entry, then each entry is nothing but some kind of function. Okay, or more carefully if you see, that is also people are telling functional. Okay, each entry. So just restrict yourself on function. It means that in a space it might possible I have some kind of element that is represented by functions. Okay, so I have some kind of a space where each entry in form of functions. Okay, and this space I am going to tell as a some kind of functional space. Again, whenever we will come to the functional space, at that time I will define, or more carefully you can tell that a space of functional space is not correct. So more correct is spaces spaces where element is represented by function. Okay, so either people are telling functional space or function space is more correct. Okay, so far what we have actually seen, if I have some kind of dynamical system, and very simple dynamical system I have taken, that is linear time invariant dynamical system. So it might possible I have three different kind of space. Okay, one space where each element in the space in the form of column vector. Okay, I have second kind of space where each entry in form of matrices. I have third different kind of space where each entry in form of function. Okay, and it is possible to show that using these three combination I can able to represent any dynamical system. Now you can come to the nonlinear system. Okay, and for time being I am going to consider the force system. Okay, so force system x dot equal to fxu, generalized system I am going to take, and here I am assuming x belongs to Rn. What does it mean? I am going to consider some kind of column vector where each entry is real number, and here this is represented, means this state of this system is going to represent in form of column vector. Okay, here what happens that I have fxu, I don't know the form. Suppose that I have some kind of general form like that, I have something like fx plus gxu. Large class of system can be represented here x into u. Okay, so if you see this kind of system, and if again you can analyze this particular thing, and suppose here I am assuming that u belongs to Rm. So again this particular quantity, that is Rn cross m. Okay, so basically you can see that here n cross m matrix comes into picture, and each entry is function. Okay, so what we have observed here, that if I try to draw the space of this GS, okay, then that is combination of the matrix, so a space as a matrix space, and whatever entry that is in form of function. Okay, so it is possible to show that engineering system is evolving in a space where I can represent system either each entry I can represent using column vectors, okay, or in form of matrices, or in form of functions, or combination of these three. Anyone has confusion? Anyone has confusion, then please let me know. And now after defining the space, what we have to do, I have to play, I have to make some kind of rule. Okay, I have to make some kind of ground to play in that particular space. Okay, so I have to formulate some kind of rule now. Okay, so now let us come to the same. You can see that this kind of algebraic structure I am showing in each and every lecture. So I have already told you that I have set, I have boundary operation, then magma comes into picture, and if this magma satisfies some kind of axioms, okay, then that will form the group. Okay, so in the previous class I have talked up to this thing group. Okay, and after that what I am going to do, I am going to add one more operation. Whenever I am talking about group, then group will only group has only one operation. Okay, but sorry, whenever I am talking about ring now, then I have two operations. Okay, so group, whenever we are, and in the previous class I have talked about lot of group now. So I know that whenever I am going to talk about ring, at that time in place of one operation I have two operation. Okay, and after that now you try to see that I have two operation, means you can define operation like addition and scalar multiplication or some kind of multiplication. Okay, now not scalar multiplication, just multiplication. Okay, now after that what happens, if they will satisfy property of associativity, then we are going to tell as a ring. Okay, now if they will satisfy two more property, identity and inverse, then we are going to define that as a field. Okay, so I have some kind of a scalar. Whenever you are talking about a scalar, then most of time in engineering problem I am talking about real number or complex number. Okay, so I have two different kind of a scalar as a real number or complex number, and we are going to work on that only. Okay, but suppose that if you are going to talk about chemical reaction, at that time my scalar is different. Okay, if you are going to talk about quantum mechanics, at that time my scalar is different. Okay, and based on that now you can see that whenever we are talking about field, so at that time I have two operation and rule from here to here, all rule from here to here, that should be satisfied. So a scalar with some kind of axioms, that is called field. Okay, now if we arrive on the field, at that time if now if I stack the scalars, okay, and how one can stack the scalar, either in form of column vectors, either in form of matrices, either in form of functions. Okay, so then what happens that I come up with that space. Okay, and so I come up with some kind of a space that is called vector space. Okay, where entry might be in form of column vector, might be in form of function, might be in form of matrices, or combination of these two. Okay, so in that space I am going to define two operations. Okay, one operation is called the scalar multiplication and another operation is called vector addition. Okay, vector multiplication we are avoiding, I will tell you why. Okay, by taking one counter example why people are avoiding that. Okay, so definition, whenever I am talking about vector spaces, so now I know that what is meaning of a space. Okay, so I have a space where each entry either in form of the column vector, either in form of functions, or either in form of the matrices. Okay, after that now I am going to add one more terminology that is called vector space. This space is also somewhere, if you read, then this is also called linear spaces, so meaning is almost same. Okay, so in this space each element in form of some kind of triplet. Okay, where you can see that whenever I am talking about vector space, then property of abelian group, so abelian group should be satisfied. And what is meaning of abelian group? I have to make sure that four property, okay, associativity, inverse, and after that here just you can return back here, then you are able to understand associativity, identity or inverse, and after that I have this closeness property that should be satisfied. And since we are talking about abelian group, so commutativity properties that also should be satisfied. Okay, so what we are telling that I have some kind of element in form of column vector, in form of matrices, or in form of functions or combination of that, and that is going to satisfy the property of abelian group with respect to two different operations. Okay, after that what I am going to do, a field, and I am going to define field. We have already seen that how basically we are going to define the field. Whenever we are going to define the field, at that time we are going to consider two different operations on a scalar. Okay, and that is vector, that is addition or multiplication. And after that, once things are ready, then we have to make sure that some axioms comes into picture. Okay, so in this way we have defined the vector space. Okay, now before going to the vector space, just in for the sake of completeness, I have also defined what is meaning of ring. Okay, so up to here we have seen that how to define the group. Okay, and we have also seen that how to define the abelian group. Okay, so group with commutativity is called abelian group. Okay, in these two things, what I have, some kind of a scalar I have, and I have some kind of one binary operation only we are considering, and after that we are verifying 5 rules. Okay, and then we are telling that that is a abelian group. Okay, now in top of that, what I am going to do, I am going to add one more operation. So one more binary operation I am going to add, and you can see that how basically ring is different from the group. Here I have these two properties. So here associativity is there with respect to multiplication kind of operation, and several times I have repeated that multiplication doesn't mean that classical multiplication. Okay, but if you take the real number or complex number, then same kind of things comes into picture. Now after that this property should be satisfied, and in cryptography, okay, I have already give some kind of hint of cryptography. People are using this concept too much. Okay, so this is very relevant for the practical application. Okay, now these are the example. So either you can take z, q, r, means z is the integers. Okay, you can take some kind of rational number, real number, or complex number. It is possible to show that will form some kind of ring with respect to addition and multiplication. Okay, so what you have to do, please check all property is satisfied or not. Okay, it is not difficult to check that all property is satisfied. Okay, and due to that reason I am not going to check. Now if you take some kind of matrix, okay, here m2z means each I have 2 cross 2 matrix, and here I am assuming each entry of this matrix is some kind of integer. Okay, it might possible that is positive integer or negative integer, I don't mind. After that we are defining two operation, classical addition and classical multiplication, then again that will form group. Okay, ring. Okay, now since I have two operation, due to that reason I am telling that as a ring. If you take just one operation, it is possible to show that multiplication or addition, please check it, that will also represent the group. Okay, now suppose if I have some kind of continuous function, okay, then it is possible to show that this continuous function, if you define multiplication, this is called addition, means this is pointwise addition, and multiplication, if you define pointwise multiplication, then again that will form some kind of ring. Okay, so please check it. Okay, because if I have some kind of function and I have some another function, okay, and if I will see the pointwise, so and if I am going to add this, then that is just addition of number. Okay, if you are going to multiply these two, that is multiplication of number that comes into picture. Okay, so you can see that in this particular example, here again I have, this is nothing but some kind of column vector where one entry, this is form of matrix. Okay, where might be I have taken 2 cross 2. Okay, and here I have taken some kind of example of function, only one dimensional function. So actually in some form of column vector where entry is some kind of function. Okay, whenever we are talking about column vector, so that is more generalized, here entry might be some kind of constant. Okay, so in this way we are able to see that if inside a space vector in form of the column vector, in form of matrices, in form of functions, and if I define two different rule, okay, two different binary operation, and then it is possible to show that under some situation, if I select the proper way, then all property from here to here that will satisfy. Okay, so in this way we are giving some example of ring. Okay, now in order to define the vector space, I need the definition of field. Okay, because what we have seen that whenever I am going to define the vector space, okay, at that time I have a space that is coming like this. Here each entry column vector, then each entry is some kind of a scalar. Okay, some kind of a scalar that comes into picture, or here I have some kind of functions. Okay, so in order to define vector space I need a scalar. Okay, and I have to extract that scalar either in form of column vector, in form of the matrices, or in form of the function or combination of these two. Okay, so whenever I am going to define the field, okay, so what we are telling that a field is a set together with two binary operation, and here I am defining addition and multiplication, but you can define addition and multiplication based on your requirement. If you have two chemical reaction, then you have to define addition and multiplication in different way. You have to, if you have you are dealing with quantum control, then you at that time you have to define addition and multiplication in different way. Okay, now what we are telling, with addition I know the set, but with respect to addition that should be abelian group. All five properties should be satisfied. But with respect to multiplication, you can see that that is also again going to form abelian group. But at that time, we are going to exclude the zero. Why we are going to exclude the zero? Anyone could you please tell me? What I am telling, that whenever you are going to define the field, then we are telling that with respect to first operation, okay, I have selected some element f, and I am going to apply addition kind of operation. Either you can represent like this, that going to form some kind of abelian group. Okay, abelian group means closeness property is satisfied, associativity is satisfied, inverse is satisfied, and identity will satisfy. Okay, and abelian, so commutativity should also satisfy. Okay, so there is no restriction here. But in second operation you can see that what I am telling again, that will going to form some kind of abelian group. Okay, but at this time I am not going to include zero or some kind of element. Now you can see that definition of zero in different space is different. Okay, so could you please tell me that what is meaning of zero in zero for some kind of column vector? Anyone? What is meaning of zero? If I have only one element, then what is meaning of zero? Anyone? Definition of zero, I have already told you that I have some kind of quantity. If I add this zero to here, then same quantity should be returned. Okay, now if I have matrix, then it should be zero. I have function, then function should be, what happens that this function finally for some particular combination that should be zero, such that if I add this function to any other function, then that return back to zero. Okay, so that kind of condition should satisfy. Anyone has confusion? So I have to exclude that zero. So definition of zero, that is depending on the situation. Okay, so field, whenever we are defining field, at that time I am taking a scalar and I am defining some kind of operation, addition kind of operation, and this form abelian group. You can take the real number, then you are able to see that these two properties satisfy. And after that, now you can see that associated with every vector space is set of a scalar. I have already told you that whenever I am now going to talk about the vector space, at that time I am assuming that each scalar will satisfy the property of field. Okay, either that is in any form, either in form of matrices each going to satisfy, or either in form of functions that is going to satisfy the property of field. Okay, so I have already told you algebraic field, and our purpose, I have most of time we are just dealing with real number or complex number. Complex number for analysis, real number for measurement. Okay, so we are doing. So now you can come up to the definition of vector space. So what is definition of vector space? We are telling that a vector space X is a set of element called vectors. Okay, and now you are able to understand what is meaning of vectors. Okay, so vectors may be column vectors, vectors may be matrix, vectors may be some kind of function. Okay, these three kind of vectors we are considering in our analysis with two operation. Okay, because whenever we are considering vector space with respect to each operation, that should be two operation that should be satisfy the property of abelian group. Okay, and due to that reason I need two operation. Okay, and obviously if we are going to talk about operation, then I have two option that I am going to add two vectors. So addition of two vectors should be on same space. Okay, but multiplication may or may not be, and due to that reason I am going to define multiplication in different way, that is called scalar multiplication. So I am going to just scale out the vector using some kind of real or complex number for our purpose, and I have to make sure that these all properties should be satisfied. Okay, so in this way we are actually define the vector space. Okay, so in next class I will give you the examples of vector space. Now it is time to conclude the today's lecture. So what we have seen in today's lecture, that I have some kind of algebraic structure, and in that algebraic structure I have some kind of scalars, I have some kind of vectors. Okay, so whenever I am going to talk about the vectors, okay, element of vector, that is either in form of column vector, in form of matrices, and in form of function, and that is going to form the some kind of space. Okay, and in that particular space, now if I will define two different operation, okay, that is addition and multiplication, and if that is abelian group with respect to each operation, then that is going to, and if I exclude the zero for multiplication, then that is going to form the field. Okay, and now vector space is nothing but field, okay, and two boundary operation, and after that I have to define some way to add two vector or scale out that vector, that is a scalar multiplication, and that should be satisfy this much property. Okay, so now in the next lecture we are going to see some example, and after that we are going to see that at least so far what we have seen, that how basically vector space helps us to understand the physical system, because we are able to understand now that a state in form of column vectors, we are able to understand that parameter if linear system, that is in form of matrices. Okay, we are able to understand now that if we are going to talk about the solution, that is going to find some kind of a space where each entry is in form of functions. Okay, so with this remark, now class is in from my side. If you have any specific question, please let me know. Anyone? Okay, if you don't have any question, then I am going to stop the today's lecture, because I have another lecture just after this. So thank you very much.